All right, here we go with a little helpful hint video that I promised you I'd make. So as we look at periodic trends, there are two major factors that affect the trends. You can have a trend going this way, it's supposed to be left to right, or you can have a trend going up and down. All right, let's try that again. All right, so you can have a trend going left to right. It's supposed to be a straight line left to right. And you can have a trend going up and down. Okay, so there's two factors that affect the trends. Okay, let me ask you a question. In which one of these directions are you adding energy levels? Here's a hint. Okay, so one trend is adding protons. The other trend is adding, one factor that affects the trends is adding protons, and the other factor that affects the trends is adding energy levels. As you go down, you're adding energy levels. As you go across, you're adding protons, but not energy levels. As you go down, you're adding protons and energy levels. But as you go across, you're adding protons, but not energy levels. So as you go from left to right, you don't get any higher energy level than the one you start with. So for example, if you look at sodium on a periodic table, sodium starts at 3s. It ends at 3p. So you're in the third energy level in the outer shell all the way across as you go from sodium to argon. So as you're moving left to right, what's the major factor that affects is not energy levels. It must just be the positive charge in the nucleus. Okay, now as you add energy levels, the reason that even though you're adding more protons, the size gets bigger is because you're adding these energy levels, and the inside energy levels push away, the electrons in the inside energy levels push away on the outside. So if you look at the inside of these energy levels, the electrons here and here and here and so on, they're going to push away on this. So that makes the atom get bigger, but it also makes the energy required to remove an electron get smaller. It makes them less attractive to electrons because the inside is pushing the outside away. So hopefully that helps with the first three questions. Now a question as we move on. Oh, what I just told you about might help you with number 5 also, because electron affinity is attraction for electrons. So as you increase atomic number, you're going left to right. Are you going to get more attraction or less attraction? Now, the actual energy change for electron affinity and ionization energy are like this. So if you have ionization energy, it was always positive, which means energy required, which means less, the resulting particle gets less stable. Electron affinity is sometimes positive, usually negative. So when it's negative, energy is out. So just for the negatives, energy would be released. If energy is released, that means it's going to become more stable at a lower energy state. So the more negative the value, the bigger the increase in stability. And the more desirable it is. So the more energy released, the more desirable it is to gain an electron. So, which element has a more, which element attracts electrons more? The one with a big negative electron affinity or the one with a small negative electron affinity? Well, it would be the one with the big negative electron affinity. So as atoms attract electrons more, electron affinity becomes more negative. Then, when we talk about energy changes associated with electron transfers, go back to like number 4, ions formed by the loss of an electron. Is loss of an electron ionization energy or electron affinity? So go back and read over this. I'll review that section of the video. Okay, moving on to questions like number 6. We said if there are 4 or less valence electrons, they usually tend to lose. If there's 5 or more, they tend to gain. All right, so they'll lose down to 0, and they'll gain to get to 8. So if you had 5 in the outer shell, you'd gain 3. If you had 7 in the outer shell, you'd gain 1, and so on. Okay, question 7 deals with adding an electron. I kind of addressed that through here, so you might want to review that section. Remember that fluorine does not have a full outer shell. And one thing I didn't mention up here, I guess, remember I said it's sometimes positive. When is it positive? When you add an electron, it's positive in S2 and P6 elements. So when you add an electron to the alkaline earth metals or to the noble gases, you expect energy to be required. Otherwise, energy is released. All right, this one, number 8, when you get there, which one's going to lose easier? Would that be the biggest one or would that be the smallest one? All right, which one has a larger radius on number 9? Notice that one of them is an ion, so you have to decide if it's a negative ion, did it gain an electron or did it lose an electron? All right, number 10, which is the most likely to gain electrons in a chemical reaction? Would that be the big one or the small one? Number 11, low ionization energy. Would that mean they lose or gain electrons easily? So if it's low ionization energy, that means they lose easily. So which would tend to lose electrons? To answer this question, go back and refer to the graphs that you made in your Google Sheets, because you made a graph for electronegativity, and you made a graph for ionization energy, and you made a graph for atomic radius. Electron affinity we didn't make a graph for, so in general, as you go across a period, electron affinity does that, in general, across a period. I think we talked about this enough earlier that if energy goes out, what's that mean? If energy goes in, what's that mean? If energy went out during an electron transfer, did the atom gain an electron or lose an electron? So you want to go back up here and review this part of the video. And positive electron affinity, I spoke to that also, back up in this part of the video. So that's number 15. Number 16. If you go back and review the previous part of the video about the energy changes. Number 17, let me point out to you that these guys, this has 10 protons. Let's do this. Protons, electrons, that's 10. 10, that's 9, that's 10. That's 11 protons and 10 electrons, that's 12 protons and 10 electrons. Which one is the largest? Remember, protons pull electrons, and they all have the same number of electrons, so which one's the largest? Okay, notice this says isoelectronic with neon and bonds with oxygen in a 1:2 ratio. So it's going to be X O2, like that. Then each oxygen gains how many electrons? Oops, our dog forgot to sit down to get his feet wiped. So oxygen gains how many electrons? It has 6 in its outer shell, and there are 2 atoms, so what's the total gain? That's what you got to think about. How many, what's the total gain of the oxygen? All right, have you thought about it? So the gain is equal to 4. Make sure you understand that. So how many does element X have to give away? There's only 1 atom of element X, and how many did that atom have to give away? Okay, number 19. For this one, transfer my car. I thought you want to put your skates in my car. Okay. For number, we have to go. We're going to the ice rink. So number 19. Let's see, we did that. So, oh no, we didn't. So sodium has in its outer shell how many electrons? And how many of those would come off easy? And after the outer shell is off, so after the outer shell, what's another word for outer shell? Valence. Electrons are gone. It is difficult to remove electrons. All right. So think about how many come off easily. Okay, an element which gained energy during an electron transfer, go back and review that video, that section of the video. And then the element that forms an ion isoelectronic with neon and combines with phosphorus in a 3-to-1 ratio, that means 1 atom of phosphorus, that means X3P. Phosphorus is going to gain 3 because it's got 5 in its outer shell. So each atom of X gives how many? Then decide what X is. So X gives blank per atom. Phosphorus gains 3. Element X gives blank per atom. All right. There, I hope that helped a little bit. I've never tried to do that before in this way, so we'll see how it goes. And that's where I'm stopping, and now my wife has to go teach kids how to figure skate.